Hey guys, Dr. Brown here, and tonight we're working a problem that I'll have to admit threw me off just a little bit, but it's a relatively easy problem if you can see how to proceed, which I guess that's any problem, I would assume. All right, we have the integral of the square root of 1 plus sine x dx. I would encourage you, pause the video, go try to work this and see if it works out for you, okay? So we'll see how that goes, but after you work it, come back, we'll be here, okay? All right, I assumed you took a break, you tried to work it. So now let's think about it. All right, I'm going to let u equal sine x. Du then would be cosine x dx. So du over cosine x equals dx. So now I can replace sine x with u. So I have the integral of the square root of 1 plus u, and then du over cosine x is dx. And it's right here where I thought, well, what do I do with this cosine x? Now I have to admit, I finally worked it, okay? Then I contacted my youngest son and he said, oh, well, Dad, I would do this. Yeah, that was exactly right. He got it in 3 nanoseconds. All right. So and I can't carry my children's eraser dust. I have some pretty sharp children for sure. Good for them. Okay, cosine, what if we were to say, well, cosine x is what? It's the square root of cosine squared x. And you may be thinking, well, duh, sure, okay. But what is cosine squared? Ah, here we go. That's the square root of what? 1 minus sine squared x. Well, what was sine x? That was u. So that's the square root of 1 minus u squared. Okay, and that, my friend, is cosine x. So I can replace this now as a function of u. So let's do that. I have the square root of 1 plus u divided by, or multiplied by, du over cosine x. So all of this will be in the denominator. So that's 1 minus u squared. So this was 1 plus sine x and times du over cosine x. Okay, now then, you recall one of the old algebraic rules. If I have a to the m divided by b to the m, that's a over b to the m. I have that scenario here. Both of these are raised to the 1/2 power, right? So I can rewrite this as 1 plus u over 1 minus u squared, all raised to the 1/2 power. That's the square root of the whole thing, du. You'll also notice this is the difference in two squares. This is 1 square minus u squared. So I can change that 1 minus u squared to 1 minus u, 1 plus u. Sorry for the dog in the background. All right, so now the 1 plus u cancels. I have the integral of 1 minus u to the 1/2 power, but it's in the denominator. I'm going to bring it up to that's minus 1/2 du. Okay. Hopefully the dog is not too distracting for you. It is for me. All right. All right, let's let t equal 1 minus u. dt then is minus du. So I'm going to pull the negative to the other side. Minus dt equals du. So now I have minus the integral of t to the minus 1/2, and du was minus dt. So if I integrate this, I'm going to increase it by 1. So negative 1/2 plus 2 over 2 gives me 1 over 2. If I divide by 1/2, that's multiplying by 2. So minus 2 t to the 1/2. And what was t? 1 minus u. So minus 2, 1 minus u to the 1/2. U, and let's go all the way up here. U was sine x. So this is minus 2. And I'll go ahead and just put this in a square root. 1 minus sine x plus c. And that, my friend, is the integral of the square root of 1 plus sine x. That's not so obvious to me. All right, so hopefully you guys worked it and used this transformation as well as an algebraic rule here for combining those terms. All right, that's all for now. Keep studying. So why are we doing this, though? Together we're trying to build a better tomorrow, and do that how? Do that through math. Keep studying, guys, and we'll talk to you next time. Thanks.